All right, geometry, 2.6, proof statements about segments and angles. And I'm going to stress this word right here, proof. We're going to do a lot of proofs today. That's the biggest thing here. And I'm going to be honest, I know it's not going to be easy, okay? So it's super important that you are following along with these notes, that you are watching this, maybe that you play it a second time or a third time so that you can kind of see what's happening, because we will see proofs on our test for chapter 6. Okay, so a proof is a logical argument that shows a statement is true, and that is deductive reasoning. It is very logical. We use facts. We can't just say something without supporting it with a reason why we say that. Okay? Two-column proof shows this argument in a logical order, and we did some two-column proofs when we did our equations the other day, okay? This isn't the only way to do proofs, but it's the first way I'm showing you. So just remember, steps on one side with a reason on the other. We always have a reason for every step we do. And we're going to use these theorems, the statement or rule that can be proven, okay? We had that before. The key thing I want you to know when we use a theorem in our proof is do not use the theorem number, okay? Theorem numbers are specific towards textbooks, and you can't write down a theorem number and someone from another school, from another textbook, from somewhere else knows what you mean if you said theorem 27. You must use the meaning or paraphrase what that theorem is actually saying. And again, I'm going to model this for you so you can see that this isn't difficult, but you need to just keep in mind what the rule we know, not the theorem number, okay? So let's do some practice here with our proofs. And I'm going to be honest, that is how you learn proofs, is you practice them, okay? Because it's not like it's, here's the rules, follow this. They're not all the same. Every proof is different. But you need to learn the patterns and the ideas that come up, okay? So first things first, I want you to get this margin note, okay? This is so important. Always make sure your givens, whatever you have, are marked on your diagram. Now, I feel so strongly about this rule, marking your diagrams up, that when it comes to your test, I am going to give points for you marking up your diagram, which also means I will take points away if you do not mark up your diagram. So please mark your diagram, okay? Now, you mark your givens, and I'm going to also stress this one. Never mark the proof, okay? Because that's what we're trying to prove. So never mark the proof. And that's super, super important. Only mark the givens, don't mark the proof, okay? So that's what I want you to remember as we go through these. Okay, so I have my first proof here. Notice at the top I have a given. These are my givens. Anything, sometimes there's one thing, sometimes there's four things. You just go with whatever you do. And then you have your proof, which is what you are trying to prove. You know you're done when you reach your proof. Okay, that's how we know we're done. So never mark that proof, but we're going to go through in our picture and make sure everything else is marked. So the first thing it says is angle 2 is equal to angle 3. I come over here. Oh, look, there's already congruent marks. Angle 2, angle 3, that's marked. The second one says the measure of angle AXD. So AXD is this AXD, it's this big angle right here, is equal to the measure of AXC, which is this big angle. Okay, so those two are the same. I'm going to mark them with the same markings. Always mark your picture up, okay? All right, now, these first few proofs that we see, they're going to start them for you. We're filling in the blanks. So it's kind of a nice way to start these because you're not coming up with all the steps yourself. You're following along, but saying how and why were they able to make that statement. Okay, so the first statement says the measure of angle AXC equals the measure of angle AXD. How do I know that? Well, they gave it to me. That's given, okay? And just so you know, everything given is in your proof somewhere. Sometimes it's the first step. Sometimes they use it later, but they are given to you. You can use that. That's worth a point, okay? Get the easy points. So that's worth a point. Okay, now, the next two steps, they didn't fill in all of the statement, but they gave us the reason. Both of these, angle, addition, postulate. Now, as we go through these, it's important you start seeing some patterns emerge, okay? Angle addition, that was from chapter 1. That's part plus part equals whole, okay? So if you see that word angle addition, you're looking back and saying, wait, they have a part plus part equals whole. That's what I need to say, okay? Notice here, they have the whole is AXD, okay? And AXD was this top angle up here. Well, what are the two parts that make up AXD? They were nice for us. They put numbers, we're allowed to use numbers. 1 and 2 added up to make AXD. On number 3, you'll see that we have another angle addition. So I'm looking for another part plus part equals whole. And this time they're using the big angle on the bottom, AXC, and it looks like that's made up of parts 3 and 4. So we fill those in off of that part plus part equals whole. Okay, now this next step, they say the measure of 1 plus 2 equals the measure of 3 plus 4. Okay, well earlier 3 plus 4 equals AXC. And 1 and 2 equal AXD. Okay, so how did we join just those right sides? Well, remember from step 1, AXC and AXD were equal. So if we replace AXC with 3 and 4, and we replace AXD with 1 and 2, we've have the same exact equal statement, but now we have numbers or what they're equal to. What do we call that when we replace something with something they're equal to? Okay, think back a couple notes here. When you replace something with something they're equal to. If I can't be in school one day, they replace me with somebody equal to me so that the class can go on. We call that substitution, okay? So when you replace things with things that are equal to them, it is substitution, okay? All right, next step, step 5, measure of 2 equals the measure of 3. How do I know that? Well, don't forget, that was also one of my givens. So there's another kind of freebie because it was just given to me. Okay, step 6, we're filling in the blank on the statement, which means the reason should give me a hint. It says I substituted something in. Well, it looks like I took this equation from number 4, 1 and 2 equals 3 and 4, and I still have 1 and 3 and 4. What can I replace instead of measure of 2? Well, we just looked at this step, and they said measure of 2 equals measure of 3, so I'm going to replace it. I'm going to replace 2 with 3 because I know they're equal. Okay, a little side note, because sometimes I think the way this is written right here, it's hard to see. Right now I have measure of 1 plus the measure of 3 equals the measure of 3 plus the measure of 4. Okay, now think algebraically. I know there's a lot of M's and angle marks going on here, but think about this algebraically. Do you see anything that's alike? I see a measure of 3 twice. I would love to get them together. So if I want to move, let's say this one on the right to the left, I would need to subtract it to get it to the left. So I subtract it on both sides. Well, what happens is it crosses off on the left side, I'm left with the measure of 1. Crosses off on the right side, and I'm left with the measure of 4. Okay? So that's from what step 6, that's how I got to step 7 to say measure of 1 equals measure of 4. What step did I do to get rid of those measures of 3? I subtracted. So that's what I say for my reason. I subtracted. And I have, notice, I got down to what I was trying to prove. Okay? And every time I made a step, I said why I did that step. This is a proof. A logical reasoning, deductive reasoning that says how I get where I need to go. Okay? All right, that's our first one. Let's try the next page. All right, at the top of this page, you're going to notice we have some properties we're going over again. Actually, not quite properties. They are theorems, things I can prove, okay? But the key is as we go through these, you should have a recollection of, wait, we just did some of that, okay? So talking about in Theorem 2.1, congruence of segments. So these are all about segments, okay? So for any segment, the length of AB equals AB, okay? Reflexive, remember I looked in the mirror and I saw myself. Reflexive, it looks the same. By the way, I could have also written that AB equals BA, because really segment AB can have either name, AB or BA. So it's really the exact same thing. So just think, sometimes, right, sometimes I could look at something and go, wait, do I want to name that John or do I want to name that Mr. Smith, right? Maybe John Smith is his name, but I can name him John or Mr. Smith. He's the same guy, okay? So make sure you know that this is really the same thing. AB equals BA is the same as AB equals AB, okay? Symmetric property, we saw that last week too. If the segment AB is congruent to segment CD, then the segment, oops, got ahead of myself there. Then my segment CD is congruent to segment AB. Remember, that's the flip across the equal or congruent sign, right? Two things though, and they just flip-flop places. Transitive property says if segment AB is congruent to segment CD and segment CD is congruent to segment EF, then segment AB is congruent to segment EF. Okay, so we're getting rid of that connecting link. Remember that? They both equal the same thing. Now they equal each other. AB is congruent to EF. We already went over those three properties. So we're just stating it again, this time with segments. All right, so let's look at the next box, which is congruence of angles. For any angle A, the measure of angle A equals the measure of angle A. It equals itself. For symmetric property, if angle A is congruent to angle B, then angle B is congruent to angle A. Flip-flop across that congruent sign. And the transitive property, if angle A is congruent to angle B and angle B is congruent to angle C, then we get rid of the connecting links and we say angle A is congruent to angle C. Okay? Again, not new properties, just a new way of saying it. I am not going to be picky when you put it on a quiz or test. You do not have to say reflexive property of angles or reflexive property of segments. Just say reflexive, and I'm good with just that, okay? So, the next one, example 2. If angle 5 is congruent to angle 3, then angle 3 is congruent to angle 5. Which property is that? Okay, well, it looks like they flip-flopped places across the congruent sign, so I would say symmetric property, okay, symmetric. Now, you could put of angles, okay, but I'm going to tell you right now, this is not needed for me because I really just want you to really work on the properties themselves, knowing that if something flip-flops across, two things flip-flop across, that's symmetric property, okay? All right, we're going to try another proof. And it says 3 steps of the proof are given. Give the reasons for the last 2 steps. Okay, first things first, mark your picture, okay? BC is equal to AB. BC is equal to AB. Yep, they're marked, that's good. Okay, so the first thing, BC equals AB, it's given. Now, let's look at this. AC equals AB plus BC. AC, the whole thing, equals AB plus BC. The whole thing equals this part plus this part. Looks like a part plus part equals whole. What do we call that when it's a part plus part equals whole? Well, there's 2 options, okay? One of them is angle addition. The second one is segment addition. What are we looking at here in this picture? Angles or segments? We're looking at segments, so we're going to call it segment addition. Okay, and again, you probably are looking there like, how was I ever supposed to know that? That's why we take notes. That's why we practice. I'm leading you through it to start with, and then eventually your brain needs to start noticing, hey, that's a part plus part equals whole. That's segment addition, okay? All right, step 2 to step 3, AC equals AB plus AB. Well, it looks almost like the step above it, except one thing changed. Instead of BC, they changed it to AB. How can I change BC to AB? Well, don't forget, on first step, we said that BC equals AB, so we can replace it with something it's equal to. What do we call that? Substitution. Okay, so when you replace something with something it's equal to, that's substitution. Okay, another property down here in number 2. Again, I'm going to have just some blank properties on the test. You just tell me what they are. So I have angle H is congruent to angle T, and angle T is congruent to angle B, then angle H is congruent to angle B. Well, it looks like 2 things were equal to the same thing. We shortened that chain up and made angle H congruent to angle B. It is like the law of syllogisms, right? But for the properties, we call this the transitive property. Okay, where they both equal the same thing, so now they equal each other. That's the transitive property. Now, somebody has asked me before, well, can I put substitution? And to be honest, yes, you can, because it is substitution as well. Okay, here's the big things. Transitive property, you need a whole side equal to a whole side and replace those sides. That's transitive property. Substitution property, you can replace one little item in the middle of something, and that's just substitution. Okay, but transitive needs a whole side equal to a whole side. Okay? All right, page 3. We have a couple proofs. That's what this whole page is, so it's just some more examples. And again, the best way to learn this is to go through example after example. Okay, so we start off looking at our picture, looking at our givens, making sure things are marked. So if you know that BD bisects angle ABC, prove that measure of ABC is 2 times the measure of angle 1. Okay, given, ray BD bisects angle ABC. What does it mean to bisect? Yes. To cut it in half, which means this side and this side are now equal. So I'm putting some congruent marks in. It's small, but it's going to remind me that those two are the same, okay? So, key things here. Anytime you see a vocab word, it is going to help us in our proof, and we're going to use that as a reason. Okay, so first things first, how do I know BD bisects ABC? It's given to me, okay? When you have a vocab word in a step, you should use it to get your next step by using its definition. What does bisector mean? It means that these two sides are congruent, right? It means angle 1 is congruent to angle 2. It's just what I marked, right? If I'm marking it, it needs to go in my proof. So angle 1 is congruent to angle 2 because of definition of bisector. Okay, so if you see a vocab word, mark it in your picture and then say for the step, write down what you marked and then say because of its definition. Okay, this next one is something that you need to know about, and as we see this, this is going to come up over and over and over, okay? So this is one you need to become familiar with. Anytime you see definition of congruent, and I'm going to be honest, that's about how I write it every time in a proof, definition of congruent. It is a switch, okay? It is a switch between congruent signs to equal signs, or from equal signs back to congruent signs. Anytime you switch between congruents and equals or equals and congruents, the reason we're going to use in our proof is definition of congruent. So if you see definition of a congruent, we want to switch from a congruent sign to an equal sign or an equal sign to a congruent sign. So currently on step 2, I have angle 1 is congruent to angle 2. I want to switch it. I want to make it equal. Well, be careful. Angles are congruent. Numbers have to be equal. So to make this, I need to say the measure of angle 1, because that would be a number, equals the measure of angle 2. So I switched from congruents to equals. Okay? All right, in step 4, measure of 1 plus measure of 2 equals the measure of ABC. Okay, where is that coming from? Look up here in the picture. Measure of 1 plus measure of 2 equals the entire ABC. Part 1 plus part 2 equals the whole thing. Part plus part equals whole. Remember, there's 2 choices for that. Segment addition or angle addition. My picture sure looks like angles, so I'm going to go with angle addition. Okay. All right, step 5 says substitute something. Measure of 1 plus the measure of something equals the measure of ABC. They want me to substitute in something for measure of angle 2. Well, coming back up and looking here, my measure of angle 2 was equal to my measure of angle 1. So it looks like I can replace measure of angle 2 with measure of angle 1. That's my substitution. Okay. Think about this. What if this said x plus x equals the measure of ABC? What would we simplify that to? 2x, right? We would simplify it to 2x. So instead of 2x, I have measure of 1 plus measure of 1 equals measure of angle. I'm going to make it 2 measures of angle 1 equals the measure of angle ABC. Okay, I'm going to be honest. I do not like their reason. I don't think that's a good thing to say. Because we did this on one side of the equation, we simplified, okay? That's what we did. We did a simplify. Now, I need to stress this. Yes, we added those 2 together. But if you remember from last section, the addition property says I add the same thing to the left side as I do to the right side. Addition property can only be used if you do it to both sides of the equation. I only added things together on my left side here. So the best thing I can do that is called simplify. The other thing I would take is if you want to tell me I combine like terms, okay? I'll take that as well. I will not take addition property because addition has to happen on both sides of the equation, and in this case, it only happened on the left side. So do not write addition property, okay? So simplify is probably the best on that one. And if you look carefully here, it looks like measure of angle 2 times the measure of angle 1 equals ABC. What were we trying to prove? The measure of angle ABC equals 2 times the measure of 1. So we did the job. We got our proof down to match what we're trying to prove, and we're good to go. All right. Let's try this one on the bottom. It's a super short one, but it's important to see some of these properties come into effect, okay? A couple things here. I need to fix my margin because it doesn't look like I want. Just a reminder, segment AB has a line above it, right? If I just put AB without a line, that means it's the length from A to B, okay? Segment has the line above it. The length does not have the line above it, okay? And as a quick reminder, and this is why I put it here, when it has a line above it, things need to be congruent because they're actual objects we're talking about, the segments. When I don't have a line above it, it means the length, which is actually a number, so those are going to work with equals, okay? So lengths work with equals, the bars above it, segments work with congruence, okay? That's why I have this little thing in the margin. All right, so let's walk through this proof. Super short one. Okay, first things first. Given segment AB is congruent to segment CD. Okay, so I mark it. Segment AB is congruent to segment CD. Always take your givens and mark them in the picture. So step one, how do I know segment AB is congruent to segment CD? It's given to me. All right, notice step two, definition of congruent. Just like we said above, right now we are congruent. I need to now change it to equals. Okay, so I change my congruent to equal. If I change it to equal, I can't have the bars above it, so I just drop them. The length of AB equals the length of CD. Okay, so I moved from congruent to equal. Step 3 says symmetric property. Well, check out your properties. What does symmetric do? Two things, flip-flop sides of the equal sign. So I'm going to flip-flop these and get CD equals AB. So I just flip-flopped them, and that's my symmetric property. And then you'll notice at the bottom, I did another definition of congruence, which takes my step 3 and went from equal signs to congruent signs. And because I went from equal to congruent, I put the bars back on and I get CD, segment CD is congruent to segment AB. What was I trying to prove? Segment CD is congruent to segment AB, and that is what we ended with. So we're good, we're done. And just for your record, the last step when you prove is never given or prove. Anything up here that says given comes into our proof as a given. But the bottom step never, ever, ever says given or prove. You have to have a good reason from all your work to get down there. Okay, so I don't ever want to see on the reasons prove or given for that last step. It always has its own reason. All right, we're ready for last page here. All right, story problem. There are two exits between the rest areas on a stretch of interstate. The Rice exit is halfway between rest area A and the Mason exit, and the distance between rest area B and the Mason exit is the same as the distance between the rest area A and the Rice exit. Prove that the Mason exit is halfway between the Rice exit and the rest area B. Got it all figured out, right? I'm thinking that a lot of words here confuses me. I'm thinking a picture might help, right? Draw a picture. Okay. So I'm not doing anything different. I'm just taking the information they gave me and I'm going to draw a picture, okay? That's what I'm going to do to organize me. Okay, 2 exits. Okay, I'm just going to write a big segment. 2 exits between rest areas on the stretch of highway. So I have rest area A and rest area B. Okay, so I have 2 rest areas and there are exits between them. Okay, Rice area exit is halfway between rest area A and the Mason exit. Okay, I need Rice somewhere. I need Mason somewhere. And I think that's all I'm working on with, right? Rice is halfway between rest area A and the Mason exit. So this rice is halfway between A and M. So I'm going to put a little mark there, right? Like in the middle. The distance between rest area B and the Mason exit, so B and the Mason exit, is the same as the distance between A and the rice exit. So this one is the same as this one. So if this one has 1 mark, I can make this one have 1 mark, right? Okay. All right, let's get this in a proof. The picture, I think, does help me out, though, a little bit to be able to kind of organize what's going on here. Oops. I'm trying to move my page, not make a mark. Okay. It starts off, and the statement says R is the midpoint of AM. So R right here is the midpoint of AM. We already marked it, right? And it says MB over here equals AR over here. We already marked that too. How do I know all that? It was given to me. Okay, it was given in the story problem itself. Okay, notice right now, definition of midpoint. So I see a vocab word and they used it. What did we mark because of that definition of midpoint between A and M? So between A and M, what did we mark? We marked AR is congruent to RM. We marked those two segments were congruent, okay? Definition of congruent comes next. Remember, definition of congruent switches from congruent to equal or equal to congruent and flip-flops back and forth. So right now they're congruent. We're going to make them equal. Okay? The next one says MB equals RM. MB equals RM. Well, right now, RM was equal to AR, right? But up here, AR equals MB, so I can replace AR with MB. What do I call that when I replace it? Substitution. Okay? Or I could have put transitive, right? They're both equal to the same thing, so now they're equal to each other. I'll take either answer there, okay? Next one says definition of congruent. Remember, right now I'm equal, so I'm going to make them congruent. So I change that to congruent, and I cannot have lengths congruent, but I can have segments. So I put the bars back on there to be congruent. Bars make them congruent. Without bars, they're equal. All right, so if MB over here equals RM over here, so right now here I'm looking, I say both of these segments are equal. That means that M is the midpoint of RB. How do I know that? Again, as soon as I see a vocab word, I'm going to say definition of midpoint, because that is my vocab word, okay? Because the sides are equal, that's now the midpoint. That's definition of midpoint. All right, proofs, okay? As we start out today, you're filling in blanks. So think about those properties that we really went over a lot today. A lot of part plus part equals wholes, so segment addition or angle addition. We have our properties from 2.5, so addition, subtraction, multiplication, division, distributive if need be. And then we have this definition of congruence that switches between equals and congruent signs. And then anything vocab. Those are really our big ones we're looking at today, okay? So practice on your worksheet. I know this is not going to be easy the first time through. We're going to spend another day on it. We're going to talk about it in class. We're going to do some practice together. But it's so important that you try practice on your own first, okay? So try on the worksheet. Let me know if you have questions.